solving reverse problems, e.g. 2 power x equal 32. Number 6, standard form, you'll be saying positive and negative. Okay. There, oh, I'm not sharing. Oh my god. Screen. Wait, let me widescreen. So sorry guys. So indices, lesson 9, indices and standard form. I'm trying Zoom's whiteboard to see is it good, whether it's good or not, because if it's good we can just use it instead of using an external application. What else can I do? There's a much of options, but not that much. Okay, so so we will be saying today, number 1, why are indices there? Number 2, laws of indices. Number 3, zero index. Number 4, negative indices. Number 5, solving reverse indices problems, e.g. 2 power x equal 32, find x. Okay. Number 6, standard form, yeah. And finally, number 7, fractional indices. Okay. So everything is fine now? You can see the screen, you can see me writing and everything, right? Okay, let's start with why are indices there? Let me grab the book. Okay, guys, are you with me? You stop talking, guys. Yes, okay, good. Well, this chat, I think, is everyone sent to me privately. So can you send the chat to the other account, Muhammad Dow, not Dow iPad? Can you send the chat to Muhammad Dow? Okay, let's start. Anyways, so why, number 1, why are indices there? Any idea why are indices there? Why are indices there? Any idea? Why are you taking indices? Why am I explaining the lesson? To express number, yeah, it's in the syllabus. Yeah, it's in the syllabus, but why is it in the syllabus? Because, man, okay, indices make our lives easier. Okay, 2 times 2 times 2 times 2 times 2 times 2 times 2 That's 1, 2, 3, 4, 5, 6, 7, 7. So it's 2 power 7. You can, express all that in just one term, 2 power 7. So it makes our lives easier. Makes our lives easier. Okay. So that's number 1. Number 2, also it makes our lives easier. Number 2, it simplifies calculations significantly. Significantly. And you will see the rule. You will see rules. Okay. So number 2, let's say number 2. So is it clear, right? Yeah, it's used to minimize the amount of niche. Yeah, that's correct, Alma. So why? Okay. Number 2, laws of indices. So there are 3 main rules. 3 main rules. 3 main rules. Okay. Number 1. Number 2. Number 3. Okay. Number 1. Okay. If we have 2, let me get another color. 2 times 2. Okay. 2 times 2. It's equal to 4, right? Which is equal to 2 squared. 2 squared. So, and 2 power 1 is equal to 2. So we can put 2 power 1 times 2 power 1 equal 4 equal 2 power 2, right? So we added the indices, right? We can add indices, addition. So if 2 power m times 2 power n, that will be 2 power m plus n. Take care that 3 power m times 2 power n is not equal to 6 power. This is not correct. Incorrect. Okay, so this is the first rule, the addition rule. Okay, the addition rule. Yeah, we add indices when they multiply, but the thing is that they should have the same base. Same base. 1 minute, let me close the door. Okay, I'm back. So same base. So if we say that 3, let me 3 power 4 times 3 power 2. What's 3 power 4 times 3 power 2? Yes, just say Noor. Send it to me privately. Three power six. Yeah, that's correct. Which is 3 power 6. I can't. It's a big number. It's a bit. I don't know. I don't have. Let me get the calculator. 3 power 6. 700. 729. So what about 3 power 4 times 2 power 2? What is that? Yeah. Send answers to me privately on the chat. What's 3 power 4 times 2 power 2? Is it 6, 4 plus 2? No. So they have to have the same base. Same base. You add the powers. Okay, I think you understand that now. Yes, good. Noor, okay. Okay, number 2. What's 8 divided 4? What's 8 divided 4? It's 2, right? Okay, good. We say that 8 is 8 is 2 power 3, right? 2 power 3 divided 2 power 2, right? Which is 2. I'm going to send the chat to any place. Guys, please send it to, I'll rename it to send here. Rename, send answers here. Okay, I renamed send answers to send answers here. Okay, so A is 2 power 3 and 4 is 2 power 2. So what we did, and 2 is 2 power 1, right? So as you can see, we sort of subtracted 3. 2 power 2 is equal to 2 power 3 minus 2, which is equal to 2 power 1. Okay. So we subtract when we divide. So 2 power m times, 2 power m divided 2 power n, which is equal to 2 power m over 2 power n. We get 2m minus n, right? Good. 2m. Let me write it clearly. 2 power m minus n. Good. But 3 power m divided 2 power n, or even m also, will be equal 3 power m over 2 power m, not equal to 3 over 2 m minus n. This is correct. This is wrong. This is wrong. They must have the same base. The O's must have the same base, guys. Okay, they must have the same base. So let's take an example here. So 3. Let's get a hard number. 11 power 16 divided 11 power 14. What's that? (11 power 16 divided 11 power 14). Guys, yeah, should have the same base. So it's 11, 16 minus 14. So it's 11 power 2, which is 121. Good. Good. Nor is it the first time for you to come with that, to attend with us? Yeah, okay. welcome, Noor. So last rule. So we got two rules here. 2m. I'll write them clearly in the next page. So let's get the last rule. Oh, it's a bit tricky. So when he said 2 power 2 all power 2, what's the answer for 2 power 2 all power 2? Power 4. So it's like we say that's 4 power 2, right? Because 2 power 2, let me change the colors a little bit. It's 4 power 2, right? And 4 power 2 is equal to 16. And 16 is equal 2 power 4, which is equal to power 2 times 2. So we multiplied this. We multiplied. Again, it must have the same base. 2, so 2 power 3, 2 power m, 2 power, 2 power m times 2 power m multiplied 2 power m raised to the power of n. It will be 2 power mn, which will be equal to power n raised to the power m, right? So let's take an example. Find 3 power 4 all power 7. What's that? Equal 3, 4 times 7. 4 times 7 is 28. 3 power 28. It's a very, very big number. Okay, so you got the rules now, right? Let's take some examples to sort of simplify the rules. Okay, 2 power 5. We want to get the value of 2 power. Let me get a harder problem. Okay, that's right. The following as let's see. Find the value of the following. Find the value of the following. So 10 power 3 times 5 power 3. How would you get that? Any idea? Yeah, can we write 10 as 2 times 5 power 3 times 5 power 3? Good, so that will be, let me write it here. I'm gonna get a different color. 2 times 5 power 3 times 5 power 3. So if we have the power here, here's a multiplication, guys. That is a multiplication. Multiplication, not addition. It's very important. Multiplication, not addition. We can write it as 2 power 3 times 5 power 3 times 5 power 3. That will be, hello Jana. That would be 2 power 3 times 5 power 6, right? They have the same base, so we add 2 power 3 times 5 power 6. Same answer as in 125,000. Did you understand the last example, guys? Okay. You don't have to do what I did here, but I just wanted you to sort of understand it better. But you can just say that it's a thousand. It's 1,000 times 125. That will be 125,000. It's very simple, but you know, I just wanted you to understand this trick. Okay. Let's see. Let's take one last one. Number. Okay, can you explain for me? I just now entered now. Okay, Salma, what don't you understand? Okay, we were saying that 10 power 3 times 5 power 3, that would be 2 times 5 all power 3. We sort of converted the 10. We converted the 10 to 2 power 5. 2 times 5 all power 3, then that is multiplied by 5 power 3. So we said that we will sort of, the power will go to the 2 and will go to the 5. And we said that is valid because it's a multiplication, not an addition, okay? It's a multiplication, not an addition. Times 5 power 3, 2 power 3 equal, this times this, that will give us 2 power 3 times 5 power 3 times 5 power 3. And that will give us 2 power 3 times 5 power 6, which is equal 125,000. We can just say that 10 power 3 is 1,000 and 5 power 3 is 125. So it's 125 times 10,000. It's clear. Okay. Okay. Let's take a harder example. 6 power 3, 4 power 4 times 6 power 3 times 4 power 9 over 6 power 8 times 4 power 8. So let's just solve it. So 6 power 3 times 4, that will be multiplication, right? 3 times 4 is 12, so 6 power 12 times 6 power 3 times 4 power 9, right? And beneath that will be 6 power 8 times 4 power 8. So we will group the same base, group them. So 6 power 12 times 6 power 3, 6 power 8 times 4 power 9 over 4 power 8. So that will be, let me get it. Okay, that will be, why is it? Oh. 6 power 12 times 6 power 3, that will be 6 power 15. It's very big. Let me decrease its size. 6 power 15 over 6 power 8 times 6 power 9 over 6 power 8. It's 4 power 9 minus 8, which is equal 4 power 1, which is 4. So that would be 6 power 15 over 6 power 8, 6 15 minus 8 times 4. That would be 6 power 7 times 4. Okay, صح. We're very good. So we finished two things. Good. We finished this wire. We finished that. We got the marker. We finished that. We finished that. And we finished that. So we're talking about the zeroed index now. Okay, number 4. Here it is. So let's say what's Muhammad. Let me say what's Dow power 0. Let me get a smaller one. Dow power 0 is equal to what? So Dow power 0 is equal to what? 1. Good. Good. Very good. So okay, any number, it's very big. Power 0 equal 1. Very good. We can actually make a proof for that if you want. Let me make it for you quickly. Okay. So a power m divided a power n is equal to a power m minus n, right? So we know that a power m over a power m is equal to 1, right? So let's put m, let's put here, let's divide a power m divided a power m. That will be a power m minus m is equal to a power 0. And a power m minus m, we know that that's equal to 1. You got it? You got the proof, guys? I don't think you have. Just know it. I don't think it will come in the exam. Clear. Good. Okay. So far we talked about the zero index. Let me write this off here. 3 0 index. Okay, number 4. Negative indices. So we have positive indices, right? Why not have negative indices? I'll try to finish it. Usually there should be a homework, but usually I get busy, so I don't finish the homework. But I'll try to sit after the lesson exactly and put the homework. So yeah, we will reverse it to make it positive. So let me negative indices to a negative power. So what's 2 power negative 2? What does that mean? So basically that will mean 1 over 2 power 2, right? Reverse the number. So 1 over 2 power 2 is equal 1 over 4. Okay, no problem. I like this pen. So let's take another example. If you want to prove it, let's prove it here quickly. We can say that a power negative m is equal to 1 over a power m. We want to prove that, right? So let's say that a power 0 minus m is equal to a power 0 divided a power m, right? So a power 0 divided a power m, a power 0 equal 1, over a power m. Okay, let's take an example. Okay. Without using a calculator, evaluate the following. That's okay. 5 power 2 divided 6 power 0. That would be 25 divided 6 power 0, which will be 1. So 25. Good. Let's take a harder one. Number 1, number 2. 4 power negative 2 times 2 power 4. Sir, why is it 25? Okay, good. What will okay, Amr. So we said that 5 power 2 divided 6 power 0, right? 6 power 0 is equal to 1, right? Omar power 0 is equal to 1, right? Omar, are you with me? Yes, 6 power 0 is equal to 1, right? What about 25 power 2? 25 divided 1, so it's 25 divided 1, so it's 25. Did you get it, Omar? Omar, did you get it? The lesson will end at about in about 30 minutes. When we divide the numbers, we will minus it or multiply. When we divide numbers, we minus. Okay, good. So 4 power negative 2 times 2 power 4. Okay, we can say that 4 is equal to 2 power 2, right? 4 will be converted to power 2 and take the negative 2 times 2 power 4. So here we will multiply this 2 power negative 4 because 2, it's 2 power negative 2. 4 times 2 power 4. So that add 2 power 4 minus 4, 2 power 0. 2 power 0 equal 1. And actually, you can say that 2 power negative 4 is 1 over 16 times 16. It will be 1. But so just wanted to sort of expand it to sort of show you how things work. Okay, number 3. 1 minute. Sorry, I was chatting with my friend. So let's take a harder one. Okay, Muhammad, go and pray. Go and pray. I think you'll catch everything. Don't worry. If you want a 5-minute break, then no problem. If you want a 5-minute break from now, then no problem. Do you want a 5-minute break? Guys, 5-minute break, yes or no? Okay, 5-minute break. We will return 4:23. 8-minute break. 4:23. We'll come to 4:23. The class will finish at about 4:55. The class finishes 4:55. So 5-minute break, 8-minute break. Okay, I'm back. When will the class finish? The class finishes in about 30 minutes from now. Okay, let's take a harder example. Uh, 10. It's not harder, but anyways, 10 power. That's 10, 100 times 10 power 1. Number 4. Let me search. Okay, 8 power negative 6 over 8 power negative 8. Okay, can you solve 3 and 4? So 10 power 100 times 10 power negative 1, so it's 10 squared. It's 10 squared times 10 power negative 1 is equal to 10 power 1. So this is a bit tricky. So 8 power negative 6 divided 8 power negative 8. So it's 8 power negative 6 minus 8. So it's 8 power negative 6 plus 8. So it's 8 power 2 equals 64. Any did you all understand number 4? Yes, okay. So zero index is done. Okay, zero index is done. Negative indices is done. So we have solving reverse indices problems, standard form, and fractional indices. So let's sort of finish them quickly. Let's add a new page. Okay, so a minute. Okay, sorry, I'm back. So reverse indices. It's called exponential equations. So unknown indices. So 2 power x is equal to 64. What is x? Yes, for number 4, very good remark, Layla. Yes, for number 4, you can just flip the fractions and solve them because both of them are negative. So you can flip the fractions. So it will be 8 power 8 divided 8 power 6. You mean, good, Layla? 8 power 8 divided 8 power 6, which that will be 8 power 2, which is equal to 64. That's correct. But I prefer this way. I prefer this way sort of to get you familiar with the correct way of the simplest way or the easiest way to solve it. Your method is good, but it might sort of confuse people. But if you're good with it, yes, it's correct, and it's much faster. Okay, going back to this question. Reverse indices. So 2 power x is equal to 64. What is x? So let's say, let's write 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4, 5, and 6. So, so 2 power 0 is equal 1, 2, 4, 8, 16, 32, 64. Right? So 2 power 6 is equal to 64. 2 power 6 is equal to 64. So x is 64, right? So sorry, x is 6. You got it? Okay, good. Let's take a harder example. 2 power 3 power m equal 8. What's m? So 2 power, we know that this is 3m equal 8. So we go back to this table. 2 power 3 is equal to 8. So 3m is equal to 8 to 3. 3m is equal to 3. So m is equal to 1. Salma, did you got it? Salma, you got it incorrectly. Did you get it now? Yes? Okay, good. Okay, let's take another example, a bit trickier. 3 power negative x equal 1 over 27. What is x? Three power negative x is equal to 1 over 27. So let's write 3 here. 3 power 1, 3 power 2, 3 power 3. 3 power 1 is 3, then 9, and 27. So 3 power negative x is equal to 27. So as you can see here, 3 power 3 is equal to 27. So x is equal to 3. Yeah, that's good. What about this? 3 power x is equal to 1 over 81. Sorry, 1 over 81. There is no negative here. 1 over 81. What's x? Let me write for you 3 table. 3 power 1, 3 power 2, 3 power 3, 3 power 4, 81, 27, 9, 1, 9, 3. So x is equal to negative 4. Good, you understand it now. So let's get sort of an exam style problem. X is equal to negative 4 here. Yes, good question. X is equal to negative 4 because I didn't say it's negative x. X is equal to negative 4 because there was no negative. There was no negative. Remember, the other problem had a negative here. Let me get the page. Let me just delete this page. I want to delete this page. This here we had a negative here. But in the other problem, we did not have a negative. You got it, Selma? Yes, okay, good. Let's take a harder example. Half power n plus 1 is equal to 2. What is n? You know that half power negative 1 is equal to 2, right? So basically n plus 1 is equal to negative 1. So n is equal to negative 2. Okay, good. You're with me. What else? Let me solve another problem. It's a bit. It's so last one. Let me get the blue one. 3 power negative x plus 1 is equal to 1 over 81. What's x? I will not help in this. So what's x? So I'll solve it because Salma got it wrong incorrectly. So I'll solve it. Let's see. So 3 power negative x plus 1 is equal to 1 over 81, right? So we know that 3 power negative 4 is equal to 1 over 81. So negative x plus 1 is equal to negative 4, right? So we will put, so x will be 4 plus 1, that will be 5. Yes, you are right, Omar. Salma, did you get it? Salma? Yes, good. So okay, we finished. It's good that you see yourself finishing a lot of things. We finished. Okay, we finished. Oh, let me get a different color. Oh my god, the eraser, green. Okay, why is it doing it like that? Oh my god. Anyways, we finished that. Okay, good. Standard form and fraction indices. So we still have 20 minutes left. I think we can do it. So standard form. Oh my god, it's very big. Okay, standard form. So basically, whenever you do a calculation and when you are calculating, you are calculating a big number. You on a calculator, you see the answer as the following: 2.36542178 times 10 power 12, right? Don't you see this form, guys? Yes, so this is called standard form. This is a scientific notation. It makes your life easier. It makes the life of scientists easier. It simplifies things. So let's say, so we send the standard form is a number basically. You express the number in a form a times 10 to the power m. Regardless of m, but it's a. Let me get the previous page. A times 10 to the power m, but take care that a lies between 1 and 10. So a cannot be equal 10. It's here, take care, it's less than 10. So a can't be 10. A can be equal 10. So let me give you an example from my head. Speed of light in vacuum is 299,792,458 meters per second. So express it in standard form 3 significant figures. What will you do? Okay, so Noor got half of the answer correct and Kunuz got the other half correct. So basically, first, we want to express it as 299,792,458 as something like a times 10 to the power of m. So basically, a will be 2, right? So we know that a will be 2 dot. We want to know m now. So we count. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay? So we need 8 decimal places. We will need 10 power 8 because that's 1, 2, 3, 4, 5, 6, 7, 8, right? So it's 2 times 9, 9, 7, 9, 2, 4, 5, 8 times 10 power 8. So we need to express it in 3 significant figures. 3 significant figures. So we will do like that. So 3 significant figures. So 299 take a 792 taken to 3 significant figures. This 7 will sort of approximate to 0, 0. So it'll be 3.00 times 10 to the power 8 meters per negative second minus 1. Did you get it, guys? No, Kunuz is 3 because this one is 7 because okay, good. Salma, did you get it? Hamad, other people, Omar, and Simos? You get it, guys? Okay. So, we are done. Oh, I still have some edit. Okay, good. So let's take another example. Okay, let's divide 6.4 times 10 to the power of 7 divided 1.6 times 10 to the power of 3. That will be written as 6.4 times 10 to the power of 7, 1.6 times 10 to the power of 3. So in a very simplistic manner, we know that 10 power 7 divided 10 power 3, that would give us 10 power 4, right? 10 power 4. So what's 6.4 divided 1.6? That's 4. That's 4. Okay. Let's take another example. Okay. 2.4 times 10 to the power 4 times 5 times 10 to the power 7. That will give us, any idea? You shall express the number in standard form when the examiner asks you to express it in standard form. Okay, let's continue. So what's 2.4 times 5? So wait, let's take the tens together. Good, Sam. Okay, let's take the tens together. So 10 power 4 times 10 power 7, that'll be 10 power 11 times 5 times 2.4. 5 times 2.4. What's 5 times 2.4? It's 5 times 2.5. It's 12.5. So that will be 12. 12 times 10 power 11. So we have 12 times 10 power 11. This is not standard form because a is greater than 10, right? So we need to convert it. Convert it to standard form. That will be 1.2 times 10 to the power of what? 12. Good. Good. Very good. Good, Muhammad. Okay. So let's take standard form, standard form, but negative. So, you know, the diameter. I can explain it again. So we were saying 2.4 times 10 power 4 times 5 times 10 power 7. So I think, Salma, you understand that we added the power of the tens, right? So 10 power 4 times 10 power 7, that will be 10 power 11. Yes? Okay, good. And 5 times 2.4 is equal 12, right? So Salma, you got that. The final answer is 12 times 10 power 11, right? Yeah, good. But 12 is not standard form. For the number to be standard form, it must be less than 10. From 1 to 9, but smaller than 10. Okay, so 12 sort of contradicts. So it should be 1 digit. Yeah, exactly, Kunuz. It should be 1 digit, right? So we will just convert 12, this number, to standard form. So we will sort of divide the 12 by 10 and add it here and add it to the 11. So 1 to 9. A9. Good. Okay. So standard form negative. We did it. Oh, sorry. Going back. So the diameter of a hydrogen molecule. Any idea how long is a hydrogen molecule? Let me get. Oh my. So basically, we were saying the standard form, discussing standard form, and we were saying the diameter of the hydrogen molecule. So, and I'll Google search for it 1 minute. Hydrogen molecule diameter. Oh my God, it's 289 picometers. That's 10 power negative 15. So let's write it. Write it in standard form. Yeah, it's very small. So we will say 2.89 times 10 to the power of what? It's 289 times 10 power 15. So we will take 2 zeros. So we will 10 power 15 plus 2. That will be 2.89 times 10 power 15. Sorry, 10 power 17. Good. Yeah, what? Power, oh, sorry, negative 15. And again, minus 2, that would be negative 17. Thank you, Kunuzaya. Negative 17, yeah. So it's negative 17. It's very small. So let me continue. So it's much easier to write it like that instead of writing 0.00000000000, 16 zeros. Wait, 16 zeros, then 289, you know? It's way easier to write it like that, right? $16 zeros. Okay. Okay, let's move forward. So the only remaining part is fraction indices. I don't think we have time for it. So fractional indices next time, hopefully. Okay, thank you very much, guys. I'll try to put a homework soon. And I think it's enough for today.